Graph the inequality y is greater than or equal to x squared plus 2, and y is less than or equal to negative 1 half x minus 1. All right, so here we have a system of inequalities which has a nonlinear part and a linear part. Doesn't really make a whole lot of difference. What we're going to do is graph these separately. And so we'll just start with one and then do the other. So beginning with the first curve here, which is a parabola. In fact, it's a parabola shifted up 2 units. The multiplier on x is 1, so if I go from the vertex over 1, up 1, that will give me a couple of points to judge how wide this parabola is going to be. And then, because this is greater than or equal to, I would use a solid line to draw in the parabola. If it was just greater than, we would use a dashed line for exclusion. Lastly, we need to decide which side of the parabola is going to get shaded. So I'll test with the origin here, because that's always the easiest point, which has the coordinates 0, 0. So there's a y coordinate of 0 and an x coordinate of 0. So 0 squared is 0 plus 2. All right, so 0 is greater than 2. That is a false statement, which means I need to shade the side of the parabola that does not contain the origin. So I'm shading the inside of this particular parabola. All right, now let's jump over here to the line. So with the line, y is less than or equal to negative 1 half x minus 1. I have a y-intercept of negative 1 and a slope of negative 1 half. So if I go down 1 over 2, down 1 over 2, that gives me a couple of points there. Or I could go up 1, back 2, up 1, back 2, and get a couple of points that direction as well. All right, now again, like the parabola, this is a less than or equal to, so we're including the boundary, which means we need to use a solid line for the boundary itself. All right, and then we need to know which way to shade. So again, the origin is very clearly on one side of the line or the other. We definitely want to just use that to test. So if I plug the origin into this inequality, it would be 0 for the y, less than or equal to negative 1 half times 0, which is 0, minus 1. So 0 is less than negative 1. That also is a false statement, which means I would shade the side of the line that does not contain the origin. So there's no overlap at all. So technically there's no solution to this system, but this is the graph that we would present as our final answer. Okay, so this is certainly a different set of line equations, but the way we do them is the same. So the first line equation is y is greater than x minus 2. So you want to choose a dashed line or a solid line based off of the inequality. So we want a dashed line. Then what I would recommend is pick the point that is your y-intercept, so negative 2. And then we have a slope of positive 1. So then up 1 over 1, that gives me another point on the line. I'm done graphing the line. Now I just move my pencil here, that's on screen, into one side or the other. And that's where you just have to do the same sort of test to decide which way it's going to go. So if you choose the origin and plug it into this equation, you would get 0 is greater than negative 2. Since that's a true statement, just click there, and now that will stay shaded, and you finished graphing that line. So then the other line, y is less than negative 1 half plus 1, it's also a dashed line, has a y-intercept of positive 1, and a slope of negative 1 half, so go down 1 and over 2. And then you have to decide which side of the line you want to graph or shade. So we'll try the origin again. So that would say, if you plugged in the origin here, that would be 0 is less than 1, which would be a true statement. So there you go. Now when you click, it will stay, and you've graphed it. So at this point, the overlapping regions, which are in purplish here, that's the solution region for the system. So if I submit this now, there we go.